Hi, welcome to this video abstracts. My name is Shengman. I'm the presenter of these sections. And the topic about this session is about guiding the redesign of a virtual reality-based photolithography training from domain experts' perspective, a think aloud study. And my co-author of this study include Dr. Xinhao Xu, Dr. Fan Wan, Dr. Yupei Duan, and Dr. Mahmoud El-Masri. And we are all from University of Missouri, Columbia. So virtual reality enables safe and controlled simulation of complex experiences. In semiconductor fabrication, photolithography process is a difficult process to master because it requires a lot of professional hands-on practice and training. And traditional training have several challenges, including the high cost, strict safety protocol, and limited access, which restricts students' opportunity for repeated practice. So engineering educators are turning to virtual reality as an alternative approach to train the student in practicing the photolithography process. And many user and learner evaluations specifically in this topic primarily focuses on post-sections measures such as survey, such as interview, but risking the real-time insight. So the Think Aloud protocol offers a complementary approach by capturing users' process and thinking their reactions while they are going through this task. So to ensure the virtual reality learning experience accurately mirror about the curriculum, the involvement of domain expert is very critical, especially during the system prototype. So despite some preliminary study introducing VR engineering lab training, systematic design framework for immersive learning design is very limited. So this study is part of a long longitudinal design-based research study, and the focus about this phase of the study is to evaluate the current prototype, which is the Cleanroom 2.0, by collecting domain experts' data and to understand how we can improve the products. So the research question include how do participants perceive the usability of virtual reality Cleanroom 2.0 and what insight can be drawn from participants' experience to inform the redesign of the virtual reality Cleanroom 2.0. So this system is a collaborative among learner experience research design and researcher, electrical engineering and computer science domain expert, and also software developer. So as you can see from this graph, that this VR experience started with the introduction page where user log in with their information, then transition to the warm-up area where they practice about the VR control, how to move around in the VR, and ultimately being introduced to the photolithography process and where they provided with step-by-step guidance, pop-up quizzes, and multi-model feedback during this experience. So Unity 3D, VRTK, Maya, and Blender have been used for the design and developing this product and also ultimately implemented to the MetaQuest 2. So in terms of the learning design, we incorporated cognitive theory of multimedia learning. And we also ensure to implementing instructor scaffoldings, starting with the easiest and flow into the most challenging task. And we also implemented chunkings, make sure the information has been chunked into small segments that it's made sure that it's not information overload to the participants. So this system, it's incorporate a major four-step preparation of wafer, application of photoresist, pre-bake, and alignment and exposure. So this study overall employed a hybrid think aloud method, including concurrent and respective think aloud. We included a total of 6 participants. They are all senior researchers in electrical engineering and experts in photolithography procedure. And we have used observation notes all together with the think aloud recordings. And to analyze the data, we utilize didactic coding, based on Nelson's usability heuristic and also inductive coding to capture the emergent categories not existed throughout this heuristic framework. So the usability issue that we have been targeted, they can be majorly mapped to the categories of Nelson's heuristic, such as visibility of system status, match between system and the real world, user control and freedom, consistency and standard, error prevention, recognition rather than recall, flexibility and efficiency of use, aesthetic and minimalist design, help user recognize, diagnose, and recover from errors, help and documentation. But beyond this traditional heuristic, that we also found that the usability issue that point to instructional delivery, such as participant was not able to find what was going to happen after they completed the current learning moment, and also instructional feedback and assessment, such as participant was not able to interpret what is the emoji-based scoring mean at the final report. And design considerations, we utilize the recommended design constructions framework and then map all the recommendation into different meta principles, pragmatic principle, and specific principles. So this include system transparency, authenticity of the environment, pedagogical alignments, adaptive support and flexibility, simplicity and focus, error tolerant learnings. And the more detail will be presented in the real-time presentations. So if you are interested in this topic, I highly recommend that you join us so we can discuss more about this. So according to our study finding, usability issues in VR lab training extend beyond the traditional usability concerns. And we also find the issues related to instructional delivery, feedback, and assessment. This further indicate that technical usability alone is not sufficient for evaluating the quality of the learning systems. And many usability challenges observed are closely related to cognitive load, which is a key consideration in multimedia, human psychology, and instructional design. So while the finding echo with the principle outlined in the cognitive theory of multimedia learning, such as reducing extraneous load and segmenting complex tasks, they also highlight some nuances, design challenges that specifically in the VR environment, such as gesture-based control, visual overload, physical navigations. So again, Think Aloud protocol is a diagnostic method that can provide valuable insight for designer to understand how we can improve the products. So the refinement of this current protocol has been made according to the result from this study, which we are really glad it's very useful. And we also have conducted several formal learner experience evaluation with a group of end user, and currently this data is under data analysis. This will further enable a more rigorous assessment and the instructional effectiveness of this product that we develop. So thank you so much for hearing our video abstracts. Thank you so much. I will see you in the real time one pretty soon.